Hello, I'm Advait. All right, I'm Advait, and this is Sid, and we are 12th graders at Monte Vista High School in Danville, and we are addressing goal number 14 of sustaining terrestrial ecosystems. Our product is a STEM solution that detects fire risk probability. We would like you to play the role of social entrepreneurs.
Siddharth, you're muted.
Sorry.
There you go.
The problem we are addressing is fire outbreaks, as they frequently happen during hot and dry weather and can spread unpredictably. Many cases of wildfires have been seen here in California, with the most prominent and in recent events regard the wildfires in Australia. This is a map from BBC News showing the fire hotspots of Australia on January 3rd this year. Over 11 million acres of land were burned, killing 33 people and much more wildlife, and causing billions of dollars in damage. And in more local events, the recent Camp Fire in Southern California cost taxpayers over $16 billion. Therefore, our solution is an algorithm that assesses the probability of a fire in real time. Users can track conditions that would result in a possible fire outbreak, such as weather conditions, location, and power surges. And said locations can be placed on high alert, prepped for a fire, or evacuated, depending on the severity of the situation. Frequencies of weather conditions and fire outbreaks in an area can be recorded and create pattern charts of areas to make more accurate assessments of probabilities, meaning that our algorithm would get better with time and by the day. This allows for residents to be cautious of an area or evacuate before a fire starts and reduce casualties and fire damage.
So, our algorithm would take in various inputs from various sources, such as the National Oceanic and Atmospheric Administration, drought.gov, California Energy Commissions to be wary of power lines that could also cause various fires, and other social media. We have created code that calculates the probability of a fire outbreak, and we want it to be implemented into a government website for ease of access that would then alert the general public and the residents that are present at risk.
So today, we plan on convincing you that our algorithm is worth investing $10,000 in. Our system can be up and running within 6 months.
So here's a code demo. Our end goal is to create code that doesn't need manual input, but just automatically overlays data. But I'm working on my programming skills, so I haven't done that yet. But as you see here, I'm inputting various data that would make it harder for a fire to occur. So we resulted with a very low amount of risk. And then on the right here, I'm inputting data that would allow for a higher risk of a fire to occur. Which would then result in an alert, which would alert the users and residents.
So there are assumptions that a lot of costs goes into development. However, there are costs for deployment of the app and maintenance after deployment. So we estimate that deployment and development of our app is $10,000, and maintenance would be $10,000 per year per license. We intend on targeting large organizations and governments, and the cost is therefore justified, as it could be a loss of $10,000 or a potential loss of up to billions of dollars.
Right. So our first step requires, so for our sales and marketing, our first step requires us to complete our program and create a fully functioning algorithm, and that would automate the data acquisition process so that the person doesn't need to manually input data as seen in the video. Once that performs well, we will move on to our next step. In the next step, we would want to target California public agencies such as California Environmental Protection Agencies, the park services, and like the fire departments. However, if this doesn't fall through, we will move on to Plan B. Plan B would be to market to private organizations such as Google, which would then overlay information about fires onto Google Maps and therefore alert users. And from there, we would expand further.
So other similar fire probability assessments do exist, but none take true advantage of rapidly changing weather conditions and fast updates, along with utilizing these statistics to get better over time. We don't plan on specifically targeting the general public, but the fire updates can be made quickly and efficiently by people in the government, and all fire data can be made public on a .gov website. So as you can see, that map is from CPUC Fire Map. It is like the first Google search result when you look up fire map, and it's updated every day at the most when in times of emergency. But our map would be updated like every 5 to 10 minutes. So we can see how a fire situation can develop and we can react accordingly.
I'm Advait.
And I'm Sid, once again.
We are the Advanced Fire Mitigation Team. We are requesting $10,000 for the research and development of the application, and we will scale up with a subscription model to various organizations. Thank you.
Thank you.
Thanks. I have a couple of questions here.
Sure.
You mentioned that the data sources are, I mean, you have the slide basically presented like many data sources, which is really good. Some of it potentially would be real-time data sources. But the actual algorithm that you demonstrated was merely maybe a weighted sum average kind of a computation. In order for you to basically say like, hey, mine is valuable and differentiated, like, can you articulate like why it is different?
Sure. So so the code demo obviously was very rough, and we don't like, this is not anywhere near what the actual what the actual app will look like. And we intend on having it like for every location, it would update with those set values automatically and then display it on a map. So as like on the CPUC fire map, for example, it has like high risk areas in red and lower risk areas in yellow. And that's something that we would do, but it would be much faster. So we could simulate how a fire situation might evolve over time.
Hi, this is Samina here. Thanks for your presentation. I think as a potential investor, what I would want to know is a greater competitive analysis. Like you said, there are products out there that exist, and if the only difference is that yours is every 5 minutes versus every day, I'm not sure that a public agency would be able to afford $10,000 per month. So I would want to know kind of a greater value proposition from you guys. I mean, you may not have that answer right now, but I think that would be kind of my major concern, particularly given kind of budget cuts within government agencies in general, and how many agencies would you really be targeting? I mean, there's probably only one that you could, or two that you could sell to, not such a, because they're
Sure.
well.
I mean, I understand. And one thing I wanted to clarify was that we were planning on charging $10,000 per year and not per month, because yeah, $120,000 per year is an exorbitant amount for something that we are doing. And yeah, we don't know exactly how, like which agencies would be hopping at the chance to at this product. So yeah.
I had a brief question, kind of building on the other two questions. I'm just wondering if you've been able to verify some of your assumptions about high-risk areas. In particular, I'm thinking about how this would be used in a private market. You were saying if public agencies aren't able to afford it or they're not interested, then you'd go to private market, which to me means insurance agencies, which means changing cost of home value or potential liabilities. So I'd like just to have some better idea of how you validated some of the assumptions about what makes an area a high risk.
Advait, do you want to answer?
Yeah, so there were definitely some assumptions made, but a lot of them were from reputable sources, from a scientific journal. I can't remember what the name was, but there was a certain formula that would estimate what exactly the risk would be, but it was also an estimate, so it's not necessarily 100% true. Whatever the formula spits out isn't necessarily true that a fire will occur, but it's not 100% accurate. It is still assumption.
Thank you.
Yeah, I have a follow-up question on that. Given the, I would say, like the problem statement of like billions of dollars of what do you call taxpayer money lost, given that it is a large sum, have you had a chance to just reach out to any of the agencies to see what they are doing today to better understand, like, okay, is it a problem worth solving, or if they already have some good solutions today already?
No, we did not reach out to agencies.
Then I'm going to go back to that question just a bit. I guess my mind went to insurance when you said private market because you're describing property value. But I also think that in the last several fires we've experienced here in California, there's also been loss of life, both human and animal. So I think that that's one other area that could be quantified as a potential liability in this particular project as it relates to the overall good. Did you have any factors or any information that maybe looked at population density within areas of higher risk? So for example, the Santa Rosa fire, it went very quickly through a suburban neighborhood. So do you have any examples?
Advait?
Can you repeat the question?
So did you study particular areas related to human and animal loss of life?
Yes, but like there are other human factors that could also lead to fires. So those are also like factors that you also need to factor in when you create like the risk of fire.
So in preventing fire, your hope is to prevent property damage, but it's not necessarily related to preventing loss of human life.
No, we want to change the well-being of humans for the greater good. It's not necessarily about the property damage, but more so life in general.
So I think, if I may, sorry, the goal for us, the personal goal is to have like an advanced warning system, so certain areas can be placed on alert, and like those places can be evacuated or perhaps prep for fire by like digging trenches around an area, so we can like defend a place from fire. And then we like with a map like this, we can also prevent like important wildlife habitats from also being damaged or destroyed in a fire.
Thank you for clarifying that. I know it's a hard question. Thanks.